Hey guys, welcome back to the third devlog in this series that I'm doing. So to recap, we're just trying to develop a Java game engine using all the concepts that I've learned in this game programming course. So I think what we covered last time, as you can see, is a simple Java application, but we have support for the runtime, which is the game loop. We have keyboard input, and I think we added the JavaScripts as well. So those were 3 modules, and the last video was pretty long. So this video, I'm not going to make it that long, or at least I'm going to try. But what we aim to do this time is first fix this flickering with the rendering, because we finally covered it in the course itself, so I can add it now. And then we're going to increase that FPS so that things will move a bit faster. And next, what we'll be looking to add would be either images or sounds, because they have provided some modules that we can use, or we can also try to use any of the modules provided by Flavor. Well, what I'm going to do is I'm going to take the modules that Sir have provided and restructure them so that I provide an API developers can use that is really similar to what Flavor does. So Flavor has sound, and you can create a sound with volumes or different clips and just call sound and use them that way. I'm not sure I'll be able to implement all of these methods because I don't think we did that with SIP, but we can see how far we can go if we ever get there. But I'm mostly be focusing on adding graphics to this engine so that the developer would just have to say create graphic. I think I have it in the game app. They just say create graphic, and then inside of one of the scripts they can just say use graphic, and then the engine will worry about rendering that graphic for that particular Java clip. So those are the 2 main things I want to get done, fixing up the rendering and using graphics. And then maybe if there's still some time, I'll look to start adding sounds. But we've covered a lot of content since then, although it may not seem like much, but we've even moved on to using filters and those different things. And I don't think Flavor supports filters directly, although you can do that as yourself using paintings. But the concept of the render loop and why it flickers is, I think, what we should discuss first. So let's get started. So I have a paint program right here, and what happens is something to do with, so let's just say this timeline is time as time proceeds, and I'm going to use really large numbers just to help you grasp the concept. But let's say that there is your game engine and you have it looping probably 5 times every second. So let's section this off into seconds. So that's 1 second, that's another second, and this is a 3rd second. And then inside here, your game engine probably does a render 1, 2, 3, 4, 5 times. So it goes 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and so on and so on. So 5 times every second, our engine does its loop, does its tick, does its render, does its updates and everything. But we're focusing on rendering. However, you notice that we try to draw all our graphics. If I go to the Java screen, no, I think it's in Java. Yeah, in our render engine, we try to first clear the screen and then loop through all of our objects and draw them one by one. However, the monitor display on your computer has a different refresh rate than the updates or the tick rate of our engine. So maybe the refresh rate, it refreshes every let's say 5 times. No, not 5 times. Probably like 8 times every second. So the blue indicates the refresh rate, and probably the refresh rate is a different rate from our loop. And sometimes they collide, sometimes they don't, but most of the time they're not in sync. So when one of our loops fire off, and then it begins to start calling this draw function, it might be able to clear the screen. It will give the PC the instructions. The screen is supposed to be cleared. And then as soon as it gets the instruction to render one game object on the screen, the refresh rate captures that at that particular point in time, and it renders it. So you just see only one object. And then probably after that, the other Java clip would have been sent to render, but it had not been captured. So it's sent to render, and then it gets cleared again, and then the refresh rate probably now captures that again. So instead of seeing 2 clips, you just saw one, and then in the next frame you saw a blank screen, because these are sending instructions to the screen one by one, but at any haphazard moment in time, the monitor's refresh rate will just capture what's there at that point in time and just display it. So there's no real way to synchronize everything. So the best way that Sil went about doing it was drawing to, in JavaScript, it's called an off-screen canvas. You draw into a still image, and when you have the entire picture there, then you just draw that once on the main frame. So no matter when the refresh rate decides to capture the screen, it would always just have that one image representing the entire frame, instead of us trying to draw to the screen directly and then it just taking what it gets at that point in time moving on. We're drawing everything to a frame, like an image, a buffered image, and then we just draw that buffered image one at a time. So no matter when it decides to take something from the screen and show it to the user, it's always going to just see that buffered image in one way or another. That's going to have everything to it, because we draw everything to the buffered image first, and then we display it to the screen. So that gets rid of all these draw calls. And how Sir does it is, I believe it's in his game panel. In his render, he draws the game objects on the image by drawing the background and drawing everything onto the image's context. And then at the end, he simply draws that image on the main screen. So what's funny about this is it's kind of like a few lines of code, and that could have solved a problem from the previous week, but we would not have known because I had not learned it yet, and I did not want to Google it. So for caching purposes, I think at the top I'm going to create a buffered image similar to how he does it. And we have this handled in our game screen. So I'll let the game screen handle everything here. So in JavaScreen, we're going to have a private buffered image. We're going to call it, let's just call it off-screen canvas. That's just for convention. Obviously, I'll have to import that buffered image as well. And then I think for the clear screen, rather than just having a blank screen, because there may be some alpha issues, I'll just draw a white screen to the buffered image. So on clear screen, I'll first, I think, how it's done. Do we have to initialize that image? We do. So in our constructor, we also say off-screen canvas is equal to new buffered image. The width is going to be the size of our application screen, and the height is going to be the size of our application screen. We're going to allow RGB, so we leave this map right there. Then inside of the clear screen, what we want to do is get the context of the buffered image. And we can do that directly by saying graphics 2D context. We could probably just replace a lot of this code here. So instead of game panel at get graphics, we just do off-screen canvas at get graphics. We want that to be context 2D by default. So rather than having two variables for them, we can just cast it directly. And at the end, we will just dispose of the context here. So we get the off-screen canvas, we get the graphics, and then we draw the screen background, which is our background color. Our background color would have been, well, I think we set it to green at the moment. Background color is equal to green. But in the future, we will allow the developer to change that background color. So we expose a variable from the front end that will let the developer be able to change that value. Then, after we've cleared this screen, in our getContext function as well, instead of returning the game panel context, we'll return the off-screen canvas's context. So we get those graphics. But what I'm thinking we can do is turn it, return the casted version directly. So it's going to be graphics 2D. And we're going to cast it directly. Graphics 2D. So now, in our Java, we clear the screen, which kind of just paints the screen as the intended color that we want to paint it as. And then we get the context, but it's going to be graphics 2D directly. As a result, we do not need a lot of these functions, so I can restructure some of this code. Since context extends graphics, it also has the context.dispose function. And now we're going to render onto this context sent from the image itself. And after we get those graphics and we've drawn everything, the final thing that we want to do is draw that entire thing on the screen. So we'll handle that in screen. So I'll create a function called screen. I'll say screen dot draw screen, and we're gonna pass in our, well, we won't need to pass in anything since screen controls the off-screen canvas. So let's create this method. So inside of screen, right on the clear screen, I'll put it above. You have a public void draw screen. And then we want to take the game panel's graphics So graphics G is equal to, I think we can use 2D. Graphics 2D. G2 is equal to graphics 2D. We want to say game panel.get context. No, let's get graphics. Get graphics. Then G2.draw image. And we're going to draw the off-screen canvas at position 0, 0. I think if I don't do anything else, it'll just draw out entirely as intended. That should draw to the entire screen because it's the entire size of the screen to begin with. And finally, we can just G2 dispose as well as off-screen canvas.dispose. Oh, we don't need to worry about that bit. So in our JevaR, we say screen.draw screen, and then we dispose the context. Yeah. So let's see if this works. It's not supposed to have any flickers. I should close this and let's run this. So I don't see any flickers at the moment. Just to test this out in its entirety, let's increase the FPS. So I'm going to create an application 30 frames per second. And as you can see, it works successfully. So there are no flickers anymore. We can increase or decrease the FPS as much as we want. And these things work wonderfully. Let's give it 300 FPS. And let's decrease the clip speed to 1 pixel. So probably do 300 pixels every second. So it moves 1 pixel every second, 300 frames per second, which is, well, 300 pixels per second, which means every second it should move 300 pixels. However, I don't think it does that because maybe your sleep function doesn't allow it to move that quickly, but that's fine. But as you can see, the higher the FPS, the smoother the application. But we've successfully made it really a smooth game. So I'm going to use 30 FPS by default from now on. And let's give it. I think that's really choppy. Let's say it's 60 FPS. Okay. So I'm going to use 60 FPS from now on, just because I like how smooth it is. But we have successfully fixed the rendering. So next, we're going to try and get the images to be drawn instead. And just to reiterate, in the application, the developer will create a graphic with a label for the graphic, as well as the path for the graphic will be. And then inside of an unload method for a JevaClip, we will say use graphic using the name of the graphic, and it should draw that graphic. So let's start with step 1. We're going to look at creating these graphics. Now, what Sil does is he uses an image manager. It has a few functions. A load image, load buffered image, and a copied image. So we're going to be mostly looking at load image and I think load buffered image. I'm going to have to crawl through the code a bit to see how he does it. But I think what the first thing we can do is just copy this entire thing and create a file inside our application. It's going to be called JevaSprite. So we have a JevaGraphic, a Java. The only difference is instead of image manager, it's going to be called JevaGraphic. And for now, it's going to have all these things. Let's see how he uses the code. So I'm going to Control F to see where load buffered graphic is. So he uses it for all the effects. And this code creates a buffered image, sets it to null. We create a file looking at that file name, which would be the path that we would have put into the file, like wherever that path is on our computer. Then we use image.io.read to read that file, and it should be stored as a buffered image directly if there are no exceptions. Then we return that. So I think we're mostly going to be using this. Let's see where he uses the load image function. So he uses it as images. So private image, but images, load image. And then I'm not sure. To draw the image, you can just call draw image. So maybe we don't need buffered images directly for our use case because we're not going to use any effects or anything on them. Yeah. I'm just gonna try. If I call load buffered image as well, these functions should still work for so. Yeah, they still seem to work just fine. So I guess for our use cases, it doesn't really make difference. So for now, I'll just comment out this code since I'm not certain that I need it. So I'll do the same with the copy image. And let's just see what our errors are. I probably just have to also define my package since I'm in a folder. Okay. So you probably don't need a lot of these things just yet. I can leave that right there. So what a graphic will do is it's just going to store temporarily that image in the memory of the application. So when they say a JevaGraphic, it needs to accept a path. And that's going to be a string. And so in here, we're going to have some private. The private image, this is going to be the source. And it's going to store this load image is going to be a private variable. And we're going to say source is equal to load image path. Now, just for convention, I want to be a bit controlling of where the developer will have to add their images. And what Sir does is he has an images folder by default, So all images would be inside here. And I think we're also going to follow that convention for our application. So they're probably just going to put the name of the image, and it's by default going to look inside of the images folder. So to that, I can say string path is equal to, and it's going to be images because we're going to have an images folder. So instead of this parameter being a path, we're going to call it we're going to call it file name, because it's going to be the name that they enter. And I think we'll need to have to join these two together. Right. I don't think you can concatenate strings using the plus sign in Java. So let's see how to concatenate strings. Concat string Java. So it's one string concatenated to another string, meaning I just have to say path.concat file name. It's going to have a slash since it's going to be nested inside of there. And the image would be stored with that way. And then we finally also have a protected image. It's going to be an accessor that only the engine has access to. Get image, and this will return the source, whether that's null or not. Generally, it won't ever be null. We should have some error handling just in case, but I'm not dealing with error handling just now. Just yet. Yeah, so we have some engines like that. Now on to our main game engine. We want this to be the focal point of where these things are accessed. So what we can do is also create a library for this. We're going to call it, instead of JavaScript library, it's going to be called JevaGraphic library. Yep. I may make it static so that the screen will also have access to it. But for now, I'll just keep it non-static, instance-based. So it's going to be a string label, and then it's also going to reference a JevaGraphic. So to that end, we also have to create those graphics. So public void create graphic. It's going to have a label, and it's going to have a file name. Now we need to do some checks because we don't want this to be an empty string, an empty file name. And we also don't want it to already exist in the library. So if JevaGraphic library.get label is not equal to null, meaning if it already exists, then we don't want to create anything. If it already exists, don't create anything. Otherwise, we also want to check if the file name is empty. And next, we also have to check for the file name. So if file name, probably have to check if it's empty. We probably have to do a string compare for an empty string. I'm not sure how to do that in Java. Well, probably I do, but let's just make sure. Check if string empty Java. Okay. So file name that is empty, then we also want to return otherwise. Now we want to create, so we want to add JevaGraphic to game engine. And what we do for that, we say JevaGraphic, we may need to import it. It's gonna be called graphic equal to new JevaGraphic by the file name. And finally, we say JevaGraphic library.put with this label and this graphic. There we go. So we store them in memory. The next thing we have to do now is be able to render them to a flavor, a Java clip. So now Java clips can have two ways to be rendered. Either with graphics or, well, I'm thinking with paintings, because currently we have that function that we can use, or we can expose it to the user so that they can draw graphics in any way that they like. But for now, let's just stick with drawing graphics. So in our flavor, in our Java clips, we're gonna have a method to handle that. It's gonna be public void use graphic string label, which will be the name of the graphic from the JevaGraphic library. So to that end, yeah, we definitely would need to make this static as well. So first we have to check to see if that graphic exists. So if JevaGraphic library.get by the label, and if it does not exist, so if it is equal to null, then return. We don't want to use any graphic. Otherwise, we want to use a graphic. So these Java clips should store a bit of a state of what they're going to be rendered as. So by default, so private appearance, I think it could be an enum. And it's going to be, I think I've forgotten how to use enum, so let's just check Java key. Enum key, okay, so it's not a capital E. So the appearances would either be a painting or a graphic. Later we could probably also support sprites or sprite sheets, but for now, we just use these two. And we call those appearances. And by default, it'll have an appearance of painting. We should handle that in the constructor. So after we set the X, Y width and height, we say this appearance by default will be a painting. And then when we try to use a graphic, we will say that this appearance is equal to appearance of graphic. And now we need another state to store that appearance. So for now, I'll leave it as it can be a 2D array, one to store the appearance type and the other to store the actual reference to that appearance, like whether it's a label or whether it's anything else. So this will be the appearance type, and then we will also have an appearance source. So this source as a painting would be a JavaScript, and as a label, as a graphic, it will be a label or a string. So for now, let's just use it as a string, the private string appearance source. And the appearance source will be empty at beginning. When we set it to be a graphic, the appearance source will be that label. So keep the name of that graphic. We can make it keep the name of the graphic, and then every time it draws, fetch that graphic and draw it. Or we can just let it store that graphic directly, and then we just use that graphic. So I think I'm going to opt to the second option. So rather than use graphic by a string, we're gonna look for that string and then return the specific graphic. So JevaGraphic graphic is equal to JevaR dot JavaClip library dot get. Ooh, I'm doing a bit of duplication, aren't I? So let's kind of refactor this code duplication. At the beginning, we're going to look to get this graphic. And then we check if this graphic is null, meaning it doesn't exist, then cancel this function. We don't want to use any graphics. However, if it does exist, then we want to store this graphic. So the appearance source is going to be this graphic. To that end, we have to make the appearance source an object. We can make it a JevaGraphic by default, and then we'd also have to make it we'd also have to make it like a painting, but we could just make it appearances by default, and appearances will with appearances be able to have an enum of the only 2 data types that we want to allow. For now, let's just leave it as a JevaGraphic. So we just set it to null at the beginning, and then we set it to this graphic. So now in our render, we have to do a check. We have to say if our appearance type is equal to graphic. If our appearance is a graphic, then we want to draw the graphic. Else, we want to draw any images. So to draw the graphic, we just have to say context.draw image. We're gonna draw the appearance source, and it's going to be at the X position, the Y position, the width, and the height of that particular clip, and then null. The observer will be null. So this function complete is expecting an image. I think that's what we were supposed to return. Our parent source is supposed to be an image. Because if we check yeah, I get it. So we get the entire JevaGraphic, but we want to get the source of that graphic. So we have to look for that. We say image source is equal to graphic dot get image. And that's what we have inside here. So this is the entire JevaGraphic, but we want to get this source. And we can just name that get source. I think that'd be better. So we get this source, and that's we set the appearance as the source. So we'll be able to draw that source directly, because appearance, it's an image with a width, a height, an X, and a Y. Okay, seems like it's still complaining a bit. Just make sure I have everything. The image class is imported. The appearance source is, I think it's because it's set to null at the beginning. Maybe if it's null, it complains. Yeah. Maybe. So if appearance source is not equal to null, then use the appearance source. Okay, so that does not seem to have any desired effects. Let's just see what our errors are. The method draw image in type graphics is not applicable for the arguments image double null. That's why. So our objects x, y, width, and height, it needs to be casted as an integer. Let's see if we can draw image with doubles instead of ints. Draw image with doubles instead of int Java. Well, it seems that what they're mostly doing is just converting it or rounding it and then drawing it. So let's also have a rounder in our utility function. It's going to be public static int round. Isn't this redundant code? Isn't round supposed to math.round Java? It rounds to its closest integer. So it's probably not even supposed to need anything like that. If we say math.round x, then yeah, it works. We don't even need a function for rounding. Yeah, so good catch. Let's just move that. And we want the x, y, width, and height values to all be rounded by default. So what we can do is, before we render anything, we can just say int x is equal to math.round, this.x, and must we record? No, that's totally strange. Oh, okay. Yeah, so we have to import record Java the line dot math. Nope. Do I have to explicitly import the math object? It doesn't seem to be the case. So let's see what the errors. We have to add a cast to an integer. That is interesting. So that could be maybe why they created that function. So now we know. Let's also do the same. So in our Java utils, we're going to re-add that function we removed. It's going to be a round. It's going to have a value to round up. Double val. It's going to return a casted integer of the math.round about. And if they're expecting a double, no, we can't do that. That's unfortunate. So we call one round int and round double. I guess just for clarification purposes. So Java utils dot round int. We won't need to cast anything because it would have already been casted. So that's for x. We do the same for y, width and height. Y width and height. And now hopefully it should use the x as an integer, y as an int, width is an int, height is an int, and it needs back the observer, which we've set to be null. There we go. All right, no longer complaints. So what we did, we kind of just rounded all the x and y positions, so it's represented as integers, so our renderer would not complain. So it's going to do all the calculations as a double precision pointed number, but it's just going to be rendered using the pixels on the screen. And if we have an appearance graphic, it's going to draw that graphic. But if we don't, it's just going to draw everything else that it had. And that seems to be all we would need in this case. So now let's actually test that it looks. We'll go to the game application. And we will create what? Use graphic. Oh, first we have to create a graphic and in an images folder. So this is where we're definitely going to need some try catches so that we don't cause some crashes, because right now I'm going to try and create a graphic called I, but that does not exist. So we get an exception, null pointer exception, in create graphic on line 45. Oh, I think that's because we forgot to initialize the JevaGraphic hierarchy. Okay, let's do that. And now let's see what the real error is. Oh, it does not complain. it probably just canceled the function because it couldn't find a file. I don't know. Let's try to use that graphic eye in this Jimmy clip. No complaints. Okay, that's fine. When we say create a graphic, when we call a new graphic, and we try to set the source, and probably it's null when it can't find anything. So in our Java clip, let's see if the source is being loaded. So we will system output using graphic here. So it's not even being called. Is it being called above? Yeah, so it's being called above, but graphic is being set to null. So it's just not even, so it's feeling gently as we want it to, but I kind of want a bit more control to know exactly where. So in our create graphic, if I set endpoints inside here, would it actually work? It doesn't seem to do so. So let's log some stuff again. Creating graphic here. So it calls a create graphic. That's before we check to see if it already exists in the library. Let's see if it calls it after. So it calls it after we check. Let's see if it calls it after. If the file name is empty, it also does. And let's see what graphic is. So it seems like it's creating it. So let's log that graphic and see. Maybe it's going to be null, something like that. So it creates a graphic. It's called JevaGraphic at this memory location, which then means that it's supposed to be inside the JevaGraphic library. So I'm also gonna log this graphic library. So the it's called name. Oh, I think I'm accessing the wrong thing. I used the label, and then the label is name, so I should try to use graphic with the label name. Right. So yeah, I think it works successfully. We do not have a graphic with that file name. So what it did is it probably just has a graphic stored as null. And then when we try to draw null, well, null is nothing. So it's empty. So we can also do a check for that and say if appearance type is equal to graphic and the appearance source is not equal to null, then we want to draw it. Otherwise, if the appearance source is null, means it's an image that doesn't exist, or we're using a painting or something else, then we just want to draw what we previously had. And we can, oh, I don't think appearance source will be null because we have it at a memory location. So let's just ignore that for now and move on to actually using a graphic. I'm going to copy over some of the things that Sue has. So I'm going to create a folder called images. And let's use a butterfly. So we're going to have a butterfly.png to capital B. I don't think it's case sensitive, but we'll try it. So butterfly .png. So before we test this, we create a graphic. We'll call it butterfly, and the file name is butterfly.png. So the engine should look inside of the images folder and create that image for us. And then in our JevaScript clip, we want to use a graphic called butterfly. And you can see that it's loaded. So we have some nice butterflies being drawn on our screen. Now, just to show you that that all of this is dynamic, what we can do is create another Java clip. So we're going to have a Java clip called JavaClip1. It's going to use this load Java clip that we're going to call load JavaClip1. Now we're going to have another Java clip. It's called JavaClip2. And for that, we will need another JavaScript to load that second Java clip. We call it load JavaClip2. It will also have the move JavaClip code, but it will not use the butterfly graphic. So we have two Java clips, JavaClip1 and JavaClip2. We have two scripts. We load the first Java clip, letting it be a butterfly, and the other Java clip, it's not. So we attach these two to the stage, and as you can see, JavaClip1 is a butterfly, JavaClip2 isn't. So we can add as many images as we want this way. And the cool thing about this is it doesn't matter what the width or the height of the Java clip is, it'll still be rendered accordingly. So in this move Java clip, let's also add some functions to resize. So if Java key dot is down and Java key dot I, and then we say clip dot height minus equal, well, let's say n, and it'll create this n variable to be something like 5. So it will decrease by 5 pixels every frame. Now if we press key, the height will increase by n. And then the same thing for the width. So if we press G, the width would decrease. And if we press L, then the width would increase. So let's see them being resized. If I press key, it should get longer because that's the Y increasing. And the renderer just renders that image to whatever the size or the dimension of that Y would be. If I press I, we decrease it, so it's shrinking. If I press L, the width increases. And if I press J, it decreases. So you can see we can resize our objects this way. Now, I'm going to test to see what happens if I go into the negative numbers. I'm not sure if it will crash or anything. It's being drawn upside down for the image, but for the painting, it's not even existing anymore. Yeah. So that's interesting. That's cool. But we can see we successfully have the rendering working as well. I think it'll be a similar process to add with sound. And he uses everything from the sound module and there's a sound folder by default as well, so all the sounds can be added like that. We can create something similar in our application. So I think this is about 1 hour so far. We could probably stretch for more just to catch up with everything Sue has. So let's continue. We're going to add sound. So to start, I think instead of going around of JevaSound.create, we're going to use the default java.create sound, give it a label, give it things like that. And then we will say things like java.play sound, and it'll be sound 1. The only problem with that is if I want to pause, I'd have to create a java.pause sound, a java.mute, and all these different things. Whereas I just want to get a sound object and be able to say sound.play, sound.pause, or JavaSound.play, JavaSound.pause. So I'll let the module be handling those things. So for the most part, it has a lot of code that I want to use in his sound manager, and I'm just going to now have a file called JevaSound.java. This could be JevaSound. So uses it as a singleton class for the sound manager to keep track of all the sounds. And by convention, we have everything in our Java engine. So I'll continue to use it that way. For now, we can probably refactor these things in the future and let the JavaClips hold the hash map for JavaClips, let the JevaGraphics hold the context or the hash map for. Same thing with sound, but for now I'm just going to deal with it with the engine directly. So in our main Java engine, let's also create the hash map. So it's going to be JevaSound library. We're going to be using JevaSounds. We also need to initialize this sound library so we don't get null pointer exceptions. And let's work on creating this rather than a general sound being a singleton inside here. We're going to have a source. So let's maximize this. And let's take a look at our JevaSound. a JevaGraphic, because we're going to be using that as reference. So we're going to have a private image source. It's not going to be an image. It's going to be a clip. Then in our constructor, public JevaSound, we expect a file name, which is the name of the sound. We will have a path folder for sounds, and we'll call the load clip with this concatenated path, just like it has the load image. So the load clip, it creates an audio stream, initializes a clip, turns it into a file, gets in the audio, gets the clip from the audio system, opens it, and returns it. So that's a lot of things. But we're going to be using this load clip function here. So inside our constructor, we'll just say clip is equal to, no, it's source. Source is equal to load clip using the path dot concat with the file name. And I think that would be it. We won't have to put anything here because that's being handled in the engine. I think we also keep store of a volume. So let's have a private float. Oh, it's already there, volume. If we set that volume to be 1. We don't need a get instance. We do need a get source. We don't need a load. Oh, we do need the load clip, but it's going to be private. We're going to use a protected clip get source, and it's going to return our source. Somehow I want this source to also have reference to the volume, but for now I'll just leave it as is. So we also will have a play clip and a stop clip, but it's just going to be called plate and stuck. I think we'd also want pause or resume, but waiting. It's going to be, rather than a clip, it's going to use our source that we created. And in our stuff, we don't get a clip, but we just want to stop what our source is. And that will be all for now. We don't actually use the volume in source code, so I'll see what we do there. But going now into our main engine as well, we basically have two functions. So we have a public void create sound, string label, and string file name. So first we want to check, so if JevaSound library get label, if that is not equal now, so if it already exists, then we want to return. And we also want to check now if file name that is empty, so they did not give us a proper string, we also want to return. And finally, we want to add JevaSound to game engine. So we say JevaSound, sound is equal to new JevaSound by the file name. JevaSound library that put using this label and this sound. Okay, I can remove these lines. So and that should be it. Then we'd also want a public void get sound string label. It is not going to be a void because it's actually going to return the sound, which is a JevaSound. So we say if, oh no, redundancy. So JevaSound sound is equal to JevaSound sound library dot get from the label. Check. So if the sound is equal to null, meaning it does not exist, we also want to return null. Otherwise, return sound. I think a lot of that was a lot of redundant code for us just saying return JevaGraphic get label. Because if it's null, it's going to be null anyways, and if it's sound, it's going to return that sound. And then on our front end, we deal with play and stop. Play and stop. So in this application here, do we attach scripts to our main game engine? We have a script hierarchy, and we have attach a script. Yeah, so we can create and attach scripts just as all the others. So what I'll say instead is java.attach script. Yeah, it's going to be a JavaScript. It's going to be a lambda function with self. So this should happen all the time. And so first we cast it by saying JevaR is equal to JevaR self. Yeah, we cast it like that. And then we can use it. So what we're going to do is say if key that is pressed space. So if the space key is pressed, then we want to say self dot treat get sound. We're gonna use a sound that we'd have to have created before, and we play it. Now the best way to do that, of course, we have to create the sound first. So java.create and sound. We're gonna call it my sound, and the path to it, well, let's use one of the sounds that it has. So we're gonna create a folder called sounds as well. We're gonna have a background sound, and we're going to have let's see how these sounds sound. Let's hit sound 1. No, that's hit sound. Let's just hit sound 1. Let's hit sound 2. Let's hit sound 3. I like hit sound 2. Correct. So we'll create a sound, and it's going to be hit sound 2.wv. It's going to be hit sound. We'll also create another sound. It's going to be background and background.wav. So now what I'm going to do is, if you press space, then, no, if you press Z, I'm just making sure those keys don't clash with anything else I have on top here so far. So if you press Z, you just press it once. Then we want to start playing background music. So get sound background. And seems like it can't be located. It's a public method in the JevaR, but it can't be located. We could probably just use this JevaR here that was returned from the get code. So rather than having to do that, we just say JevaGraphics. And we store that in a JevaSound. So JevaSound background is equal to JevaGetSound. You need to encode that. And then we say background.play. And that should play the sound. Method play is not applicable for empty booleans. I think it's going to ask if we want to play it on loop. Let's just say true for now. That's if the Z key is pressed. And if the X key is pressed, then we want background sound to stop. So finally, let's also, if we press the C key, we want to get the hit sound. And we want to play that hit sound. We do not want it to loop. So audio warning now. I'm just going to test to see that these sounds work. I think I found what the issue was. I put the books once more. So just air warning. If I press C, it should make a sound. It does. If I press Z, it should start the background music. And if I press X, it should stop the background music. There we go. So yeah, sounds also work in our engine. Now obviously I can modify this to be much more developer friendly. Instead of having to first get the sound and play it and get it and play it and get it and play it, I could probably just do Java.play sound and just do that once. Ideally what I want to do is store the sound clip, set its volume, set its looping, and then when it plays it'll work according to what its loop value is and stuff like that, and make things more accessible through this game engine rather than through separate classes. But for now we can see a game coming along. We have some images, we have drawing things, we have proper rendering, and we have sounds. It's like it was a success. We kind of caught up with everything so taught us so far, and kind of modularized it. So here, I think that's the basics of this game engine. The only things we'd have to, or we could seek to create for now, would be things like sprite sheets, or paintings, or other things like that. More functions on the sound module as well. But those things would actually be really complicated, like sprite sheets, getting a sequence of images and animating them over time. So that'll be something interesting to work on. Yeah, it's going to be really different from how I created it in Flavor. and that's because it's a lot more complicated in Java, so I tried to create something much more simple. But I probably do something like create SpriteSheet and give it a label. Then I'll have it an unload function in that SpriteSheet that just lets it store a lot of images that it wants to use, as well as the time for that image, how many milliseconds. And then in the game engine where we say flavor that use SpriteSheet and we give it the label, then it should be animating that over and over for us so that we won't have to worry about it. I think as we're about 1 hour and a half into this video, I can even try to get that started. So yeah, let's get that started. So Sid has an animation class that does all the synchronization and updates and everything for you. And then he has like a face animation that uses this and does the updates based on the get image. So that's two things we're going to use. We're going to use that get image, and we're kind of going to use this add frame as a lambda function. But we're going to use a lot of paths instead. So we're going to have an animation. We're going to start that animation, and we're going to be updating that animation as time goes about. So the animation has a synchronized start method that increases the, well, it starts that particular animation. I'm not seeing a stop, however. So we may not get everything done as perfectly as we'd like to, but we also have the update. And then let's see, for our animation is being used in the game panel, and in the update it's being called as well. But yeah. So I think the only difference is when it starts, which is something we can fix, because all start does is set the animation time to 0. It just resets everything. Kind of also what stop will do. And then from there, it should be updating. The way we're going to do it is we're just going to store that animation in the library. And then we will have to, when a clip uses that animation, we're going to create a copy of that animation. I have to see how to duplicate animations. We're going to create a copy of that animation, and from there, when the use is first called, then we'll do the start, and from then on, in the JavaClip method, if there is any animation going on, we want to call the update. And then we want to render depending on which animation frame it is currently at. So I'm going to take this entire library, and we're just going to call it JevaSprite. I can't spell. SpriteSheet.java. So we don't have the game panel. And I think everything else we can leave as is. So in the spreadsheet, we will accept a script. So JavaScript init. So it's going to be an initialized script for the spreadsheets. And then we kind of just want to run that script. So we say init.call this. Perfect. And then in the init function is where we're going to do the add frame, add this, add that. It's also going to be using the existing images from the library. So add frame, but it uses an image, a graphic label. So it's going to be a string label. And first we check to see if that label exists. So in our Java clip, when we use a graphic, let's just split this up a side bit. We try to get that graphic first. And if the graphic is equal to null, meaning it doesn't exist, we don't want to do anything. If it exists, we want to get that source, and we want to add it to the animation. But we want to add a copy. I think we can add the row reference to the animation because it's not gonna hit. Yep. I don't think so has a get num frames. Where is that being used? It's not being used anywhere else, so we probably don't need it, but we keep it for now. And inside here we have the animation frame class and stuff like that. So inside of our Java engine, right where we create everything else, we say, well, I can mostly just duplicate this code. First, I also have to create that library object, obviously. All of these resources require data stuff. It's going to be a JevaSpriteSheet. It's going to be called JevaSpriteSheet library. We also need to initialize it. And we need to create SpriteSheet. It's going to have a label. It's going to have a label, and it's going to have a JavaScript, which is the initialization method. So we first check to see if it already exists in the SpriteSheet library, and if it already exists, return. Otherwise, we want to create a JevaSpriteSheet. I call it SpriteSheet, and it's going to be a new spreadsheet. It's going to have the initialization method. And finally, we want to put this spreadsheet in a spreadsheet library. So create a spreadsheet is going to accept the sprite's name, the SpriteSheet's name, as well as a lambda function, which is what we're going to use to add all the frames and the different durations that they should be at. Finally, inside of the Java clip, there's over here. Let's also add that appearance type. So they're also going to have sprite sheets, and we have to test for them. So first we say we have to call this use sprite sheet. And we're going to create a sprite sheet. So JevaSpriteSheet. Sprite sheet is equal to JevaSpriteSheet library that get label. And if it doesn't exist, return. Otherwise, we want to get that particular sprite sheet. So that is obtained using, well, we can probably just hold reference to the sprite sheet directly. Or we could just get the first image at the point and say something like the source will be the sprite sheet that get, well, I'll keep it as get source. So I'll rename you to be get source, and it'll get that source at that point in time. And the appearance type will be a sprite sheet. The appearance source will be a source. And then we also want the sprite sheet to start. Although rather than start, I think a better way to call it would be reset or something like that. So I'm just going to call this reset. And just hope it doesn't break anything. It does not. So we get the source, and then we say SpriteSheet.reset. Because we are about to use this animation, we want it to reset, so then we can start to use it. And inside of the render function, if the appearance is a graphic, we want to draw that graphic. Else, if the appearance is a sprite sheet, first we want to change that appearance source. So appearance source is equal to sprite sheet.get source. We're gonna have to keep changing that sprite sheet.get source over and over, which means we need to store reference to the sprite sheet as well. So let's change a bit of how the source will look, because this source can either be an image from a graphic or a sprite sheet. So let's just make this an object. The appearance source will be null at the beginning. And if we use a graphic, we want the appearance source to be that image. If we use a sprite sheet, we want the appearance source to be that sprite sheet. And then, so it's going to be J. Oh, we don't need to duplicate these. That. but just make this source. And then we say source dot reset. And finally, down when we're drawing the image, first thing we want to do is cast this to an image. So if we're drawing a graphic, then we want the appearance source to be casted to an image. And if it's not, if it's a spreadsheet, we want it to get source. Okay, so maybe we need to, you could probably just image source is equal to casting the appearance source, and we're using this source. So that fixes the first one. We can do the same for the other one. So image source is equal to, we have to first cast this object to a JevaSpriteSheet. Oh, no, we have to cast it to an image. I think get source is undefined for type object. So yeah, we need to nest, need to nest cast this and then return a get source. So we turn appearance source into JevaSpriteSheet, and then we use get source on that JevaSpriteSheet. And then we can just draw the source. Now for it to continuously be animating, we can let our clip control that. So in our clips tick, we can check if appearance type is equal to spreadsheet, then we want to get that spreadsheet. So JevaSpriteSheet is equal to where we have to cast the appearance source. SpriteSheet. And then we want to call the update. Which I'm going to name tick for conventional purposes. Spreadsheet.tick. Okay. So what we're doing here is when we attach a spreadsheet, we hold reference to the entire spreadsheet. We say that this clip is using a spreadsheet, and as we use a spreadsheet for the first time, we want to reset that spreadsheet. Then in our tick, meaning every frame, we want to update that spreadsheet as well. And if we're using a spreadsheet, we want to update that continuously, which will help it move on to the other frame as well. And finally, in the renderer, we want to get and render that. Let's see if this actually works. So a spreadsheet at the moment depends on images. So the way how Sir did his animation was inside of face animation. He used image 1, animation image 2, and animation image 3. So let's also use those animation images. It's image, animation image 1, animation image 2, and animation image 3. Yeah, so peaceful. Next, we want to add these images. So let's create some more graphics. They will be image 1, then 2, then 3. 2 and 3. So we've created some animation images, and they're all PNGs, so everything is in order. Now we need to create a Sprite Create SpriteSheet. It's going to be called face animation. And we're going to accept a lambda function, which will hold a reference to the sprite sheet. Let's just call it self insert put. And then we say JevaSpriteSheet. I think we need to import that as well. We've also already imported it. JevaSpriteSheet. SpriteSheet is equal to array cast self. So from here now we can do the entire add frame stuff inside of this here. And all of these inside here would actually just be the labels. So we created the graphics, and then we, in our sprite sheet, we're adding each of these labels as frames. And now to test this, I'm going to create a third Java clip. So it's going to have a third load. It's going to be able to move, and it's going to use the sprite sheet called what do we call it? Face animation. So let's use some better labels. Instead of it being called load Java clip tree, it's going to be called load face, because it's a face clip that we added. So let's add this clip. It's going to be called face. It's going to be using the load face script. And let's add it higher up in the screen. So we add these two clips lower down in the screen. You say something like 180, 180. This one we added about 20. And it's going to be more to this screen center. We can handle it down here. So we're going to attach this face. The Y position is going to be 50. And X position is going to be, let's say 150. So it's going to be in the center. So let's hope that we do not have any errors. There we go. So the animation successfully works. So yeah, let's just recap everything that we have created. So in this session, we added images. You can create a graphic, give it a label and the file location. And then in any of your clips, you can say use graphic by the label, and it will be drawn no matter what the size is. We have also added sound, which you can use with JevaCreate sound. You give it a label and the file location, and then you can see we can play the sound or stop the sound. Finally, you can also use sprite sheets. Give it any names, and then give it a function that captures what you want each frame to be, which are labels you would have previously created, which are graphics you would have created. So we created the graphics for different animation faces, and we use these frames in our code here at different durations. And then finally in our script, we can say use SpriteSheet face animation, and it will be rendered and everything looks like this. So you see, if the clip does not have any graphics, it uses the default painting. If it has an image, it uses the image or the graphic. If it has a sprite sheet, it uses a sprite sheet. And no matter where it is positioned on the screen, no matter the size of it, you can see that they're properly being created or drawn. Yeah, successfully and as intended. I think only the ones that are able to draw the graphics can actually be animated in the opposite direction though. So we may have to look into that to see why it is not the case for the painting, but I think that's it for now. And when we press buttons, that's why we can play audio. Or we can start and stop sounds. Yeah. I think the only thing before we can make this fully functional is add in things like collision and add in probably like a text field to display text on the screen. And what I'd like to do with that text field is give it an X and Y position on the screen and what the text should be, and the game engine will draw that text for you. You can probably also choose a color that you like it to look like and maybe a font, and the game engine will draw that for you. I'm also going to try to see if width and height also works, but I think that's out of scope for this video. So I'm going to end it there. We've covered a lot here, and first and foremost, we were able to actually cover fixing that render system. Let's play around with some code a bit. Let us use a background color of white. Yeah, so we have everything on this white screen. Success. So, I think that'll be all, guys. Thanks again if you've made it this far. Next time we will be, well, next time what I have planned is working on collision and maybe text views. So I'm gonna put some code for how that would look in a JavaScript. In a JavaScript, we will say something like if, and I'm just gonna put it in comments, if clip.hit test, and we give it a name of another clip that has been attached, such as JavaClip 2. So if JavaClip 1 touches JavaClip 2, then do something like core plus plus or something like that. And we'd also need to give JavaClips custom state so that each of them will store their own state without the developer trying to lose scope from creating different objects everywhere. And then for the text fields, we can say something like Java.create text field. We will give it a label, my text field. We will give it an X position, a Y position, a width, a height, HEIGHT, and then some text, which will be how it should look. And even maybe a color or a font. And then that will be rendered on the screen when you do attach text field, for example. Yeah. So those are some things we do on the next video. But again, the limitations are all with what we've learned so far from Sid. And I'm not going to try to do more than or below that. But hopefully by the end of this game engine, I'd get approval to be able to use this game engine in my project. Or maybe I'd use the tools that Sir is currently creating, because I'm starting to like the structure of his JavaScript files and making everything more component based, whereas I'm making everything really integrated with lots of different functions to apply to different things. But yeah, we see how that goes. But I made this a personal project to just create these files, create this game engine. So I'm just going to continue creating this game engine to see how far I can go in Java and how much we could accomplish. Yeah, that'll be all. Thank you guys for watching, and I hope you have a great day. Bye.